All right, so after all the connection, so I want to use the mobile phone now to control each of the appliances. So these are ESP Electron Automation Smart Home Web Server, and these are the buttons here. So let's control each of the appliances one after the other. This one, you can see I turn it on. This is the second one, this is the third one, and this is the fourth one. So can turn it off again. The first one, the second one, third, and that is this ESP8266 Wi-Fi module to control home appliances from anywhere in the world. So this is the code that will allow us to run our project effectively, controlling our home appliances or any appliances from Internet of Things. So this is the code. We have defined ESP8266 microcontroller in the sketch part of the code. We have also defined ESP8266 Web Server library. We have set a relay to be normally open. That means the relay pins are going to be normally open at the initial point. We have also set the number of relays pin to be 5, meaning that we are going to control different modules of relay up to 5 from the microcontroller, and we also assign each GPIOs to a relay, meaning that in our microcontroller we have different general purpose input output pins, and from the microcontroller we have assigned it to pin 5, to pin 4, to pin 14, pin 12, and pin 13. For us to be able to control these home appliances from anywhere using Internet of Things, we need to replace our local server, which can be our system, can be your phone, can be your external Wi-Fi. So this way you replace your Wi-Fi name, constant char SSID, you replace your Wi-Fi name. Here you replace your password, input your Wi-Fi password here for you to be able to communicate to ESP8266. Now let's see the whole body of the code. This is how the code looks like. If you need a code, you can request from it from the comment section, and I will do well to make sure that I will send it to you. So let's move forward to the connection part. All right, after a successful code explanation from electrical automation, so this is another part to take to achieve this project, and this part is to set up your ESP8266 board so as to communicate with your code and to upload the code into the microcontroller. Now the microcontroller that we are going to use for this project, so this is the code that will allow us to run our project effectively, controlling our home appliances, is ESP8266, and this is how ESP8266 look like. This is a picture of it. So now we are going to configure the Arduino integrated development environment to suit to our code so that we can upload it to the microcontroller. Now let's do the setup. You go to your tools box. When you click on tools, you see different explanation of tools. So what you need to do is to go to board, then from board you see ESP8266, you see board manager. So you see different board. The first one here is Arduino, and we are not going to use Arduino. You see ESP8266, and yes, that is what we need. So what you need to do is to just run to ESP8266, and inside ESP8266 we have different models of board there, and in our project we are going to use generic ESP8266 module. So I click on it, then I've selected it. So the next thing is to check your ports. Since you have selected ESP8266 generic module board, so you check the ports. Now you will notice that when you try to upload your code to the microcontroller, you'll be seeing that the code is not connected or error due to code connection. So you are seeing here we have COM11 COM3. as a serial port, but that is not the port of ESP8266. So how did you know the port of ESP826? Now is for you to slot a cord. Just pick your charger cord and slot it in your ESP8266, something like this. So when you slot it like this, the next thing is to take the head of the cord to your system. This head here, you take it to your system. So as soon as you plug into your system, this is the ESP8266. As soon as you plug in, you see ESP8266. There is a light blinking there telling you that it's connected. So what next are you going to do? You just go to the board again. So you go to the tools again, click on it, go to ports. So you see before was COM11, COM3, now you are seeing COM4. So that is the port. So you click on it. Now you have been able to connect the ESP8266 to your microcontroller. Now the code is well connected. So the next part is to upload the code to the microcontroller. How do you upload the code? First, you need to compile the code first. So how do you compile the code? You just go to compiler. This is where we have the compiler, verify. So you click on verify. After clicking on verify, you see the code is loading on your system. The code is loading. So you just wait for some time for the code to load successfully. It's still loading. So just wait for some time. After some time, you see the code successfully loaded before you upload it to the microcontroller. So let's wait for some minutes. As you can see, the code have been successfully compiled, and you should note that the reason why we compile the code is to make sure that there is no error, so that as soon as we are compiling the code, if there is any error in our code, you will see that it will indicate us it will indicate by telling us that there is error in our code, so as for us to debug it. So you see there is no error in the code, and the code have been done compiling from here. As you can see, look at done, compiling done. So the next thing is to do what is to upload the code to the microcontroller. This is the microcontroller as I showed you before. So the next thing is to just go on the sketch pad again, you click on upload. This is where the upload buttons in the IDE is. So alright, the code have started uploading to the microcontroller. You have seen the ESP8266 is blinking, telling you that the code is entering into the microcontroller now. So the moment it is 100, you see that they will tell you that the uploading is done. So we are still uploading it. You can see from here. So yes, it's done now. So after when you have successfully uploaded the code to the microcontroller, the next step is to connect the ESP8266 to a Wi-Fi module. You can use your system, you can use your phone, you can use your external Wi-Fi. So let's see it from the serial monitor. It's better you use your own network module. So I want to use my system in this case. But to the microcontroller, you notice that the first time you go to the serial monitor, you will not see any network to connect until when you set up your network to be connected to it. So you now see I've opened, this is my ESP8266 serial monitor. So they will show you connecting to Wi-Fi, and there is no Wi-Fi to connect to it. So how do you connect a Wi-Fi to this module? First thing is to go to your system. In my own case, you can use your phone, you can use external Wi-Fi. So I want to use my system to connect. So I just go to my Wi-Fi setting. I go to my Wi-Fi, click on my hotspot. So I'm hotspotting the system, the ESP8266 also. So I click it. So after that, you have seen, yeah, the ESP8266 have located my Wi-Fi and is connected to it, and that is my IP address in this case. So how to connect ESP8266 now to control any appearances anywhere in the world? You just need to type this IP address in any of your local web server to be able to control your appearances. So let me pick up any phone and to go to any web browser. So I want to use Chrome in this case. So I just open my Chrome. This to do is to copy it. I copy, and this is it. So you have seen ESP Electcom automation smart home web saver. So these are the buttons. So if I click on the button, you see from the serial monitor. So I click it, you have seen, click, you have seen. So that is how the buttons is responding. So you can use any web browser. It's not only your phone, you can even use your system. So let's go to the system and check whether I will see that. So I'll just go to my Chrome, my system. Alright, it's here already, so I can click and it's working in my system also. So that is it. So the next thing is to connect it to your relay, because it's relay that will control your appliances with AC voltage. No, our relay, we are using DC voltage to AC voltage. So let's go to the relay. This is our relay module, and in this case we are using a 8-channel relay, but we are not going to control our appliances up to 8. At least we will control 5 using 5 channels. So in this relay module, you know, relay is electrical components that the input is always a DC voltage, whereas the output is always an AC voltage. That is to say that the excitation is always DC, whereas the response will be AC. Now let's see the inner part of a DC and how we can control it. This DC have a VCC, it has in, it has ground, it has in 1, in 2, in 3, in 4, in 5, in 6, in 7, and in 8. So these are the pins that will control the AC from DC voltage. So now the ground is always connected to the ground, and the VCC will be connected to the voltage of the relay. In this case, this relay is using 5 volt DC. Now let's see the inner part of a relay, how it looks like. You know, a relay is an electronic component. So let's see the drawing. Typical drawing of the inner part of this relay. We have the coil contacts, we have the in, we have normally closed, we have common, and we have normally open. Now our coil contact will be connected to, this is the ground, and this VCC, so it can be connected to 5 volts. Now we have normally closed, we have common, we have normally open, and this in our relay is a control pin. This pin is always connected to the microcontroller, in which the microcontroller will send 0 or 1 for the relay to be energized from the coil contacts. Now we have a normally closed. Now this normally closed, once the coil contact of the relay is being energized, the normally closed will turn normally open. Meaning if the load was connected to it, the load will automatically off, and the normally open contacts, if at initial point is normally open, but when the coil contact is being energized, the normally open will turn normally closed, meaning that if a load is connected to it, once the coil is being energized, this normally open, there will be a voltage and a current flow from this terminal. Whereas the common is a common terminal where our AC voltage is always intact. At this point, you keep your AC voltage here. For instance, if we want to control a AC bulb, let's take for instance, this is our AC bulb. So, and these are AC supply with live and neutral. So what you do is that you take the live terminal to a common, and then you take your neutral to the bulb. This is my neutral, so I take it to the bulb. Now I want the bulb to turn on whenever the coil contact of the relay is being energized. So you notice that when the coil contact of the relay is being energized, the normally open will turn normally closed. So what do? I connect my normally open contact to the bulb. So that is how it is. So once this relay coil is being excited, and what will happen is that the normally open will turn normally closed, and the common will send from here down, will send voltage to this normally open, and you see here is being connected to here, so there will be a current flow to the bulb, and the bulb will illuminate. Now that is a typical drawing of this relay and the explanation. That is the inner explanation of our relay. So I hope you understand, and if there is any question, you still have to feel free to drop it in electrical automation comment section. Now let's see how we can connect the microcontroller to the relay on after the order. Alright, so let's do the connection from ESP8266 to the relay module together, one after the other. So the first thing is to connect your ground to the ESP and to the relay module. So this is my ground cable, so I'm going to connect it to my ground pin. So from the ESP8266, that is ground, so I will connect it to the ground of relay module. So I'm going to connect my VCC. So this is my VCC. Yes, so I'm connecting it to VCC of the relay. So now I'm going to connect the control pin of the relay module, which we are going to send the 0 and 1 from the microcontroller, which is connected to our phone, to the relay for us to control our AC appliances anywhere we are in the world. So now I'm going to use digital pin 1, digital pin 2, digital pin 5, digital pin 6, and digital pin 7. And as I mentioned, that is 5. So we are going to control 5 channel relay in this case. So now let's connect it together. So I've connected my D1, my D2. I see. So I will take it to in 1, which is control relay 1, and in 2, that will control relay 2. So the next thing now is to connect the D5, D6, and D7. So this is my D5, and this is my D6, and this is my D7 from the microcontroller. So I will connect it to relay pin, connect it to relay pin 4, okay, 3, connect the second one to relay pin 4, and then I'll connect the last one to relay pin 5. I'm done. So now the next thing is to connect your charger to the microcontroller so as to keep a constant 5 volt in the microcontroller. So in this case, this is my microcontroller ESP8266, and this is my charger cord. So I'm going to slot it here. Alright, that is done. So the next thing is to bring out the phone which was connected to the microcontroller. Let's see how we can control this relay module before bringing our AC load. Now this is the phone. So these are the pins from the ESP electrical automation smart home web server. So I can control each of the pin now. So let's see if I control pin 1, whether it's going to control relay 1. So you are seeing from the relay that has been controlled relay 1. So we go to 2, that is the second one. So we go to the third one, that is the third one. We go to the fourth one, that is it. So the last one. So we can also use this phone to turn on all these appliances. The last one, like that, like that, like that, till the end. We can also turn it on again depending how we want to control our home appliances. Now let's see how to connect the AC load to it so as to control the AC appliances from the relay. Now let's see. We are done with the DC connection of the relay module and to the microcontroller. Now we are going to connect the AC part of it. Now as I explained earlier, that the common is where your AC input will be terminated at constant. So we have common from the relay. These are relay, and these are the common pins. This is common terminal, this is common, this is common, this is common, and this is common. So let's connect our common AC input to the common. Now we are going to use relay 1 to relay 5. So let's connect the common to this pin. So this is the common. And note, if I'm connecting the common here, so I will keep on connecting common. So instead of doing that, what are we going to do? We are going to loop all the common together so that we will only be connected our AC load to the normally open terminal. Now let's loop all the common together. So this was the first common, so I loop the first common to the second common. Great. So I will loop the second common to the third one till we complete the 5 common. So let's do that quickly. Alright, so we are done looping all the common terminals together, from the first relay to the second relay to the third to the fourth and to the fifth relay. So all the common are being looped together. But in this case now, I don't want to use the fifth relay because I'm having only 5 load here to control. So as you can see, my load here is 5. So I want to control only 5 home appliances, which is this first, second, third and the fourth bulb. So I don't want to use the 5 channel relay, so I'm going to use 4 channel relay. So now this is my neutral terminal. So now, since I've looped all the common terminal together, the next thing is to connect my AC normally open of my relay to each of my AC load live. Now for instance, now this is my first live. This is the phase live, so I'm going to connect it to the phase relay normally open. So I'm going to connect it here. This is the normally open of this relay is here. It's done. So the next thing is to do the same method, connect the second one to the normally open of the second relay, which is this is the second relay, and this is the common, and this is the normally open of the second relay. So we'll do the same to the third one and to the fourth one. Alright, so I'm done connecting the 4 lamps together. This is the first one, the first lamp control. This is the second one connected to the normally open, the third one connected to the normally open of my relay, and this is the fourth one. So the next thing is to connect all the neutral to the neutral bus bar, and these are my neutral. This is the first neutral, this is the second neutral, and this is the third, this is the fourth one. So is to connect all the neutral together. So I'm going to connect all the neutral together. That is the 4 neutral have been connected together. So I will take it to a neutral bus bar, which is the main neutral incoming from my AC supply. So this is the neutral coming from the neutral source. So I'm going to join it together. So after that, you need to insulate it so that it will not cause spark or electric shock. So I'm going to insulate. Alright, so I'm done with that. So the next thing is to bring in AC input. This is where the live is going to, and this is my neutral. This is probably my head. So if I slot this in and connect my microcontroller, then we are going to control each of the load using our phone or our system or any mobile devices. So now let's see how it's going to work. Alright, so after all the connection, so I want to use the mobile phone now to control each of the appliances. These are ESP8266 Automation Smart Home Web Server, and these are the buttons here. So let's control each of the appliances one after the other. So the first one is this one. You can see I turn it on. This is the second one, this is the third one, and this is the fourth one. So can turn it off again. The first one, the second one, third, and that is it. So you can see, I hope you enjoy Electcom automation project using ESP8266 Wi-Fi module to control home appliances from anywhere in the world. So that is it.